Welcome back to the Deep Dive. Today we are strapping ourselves into the competitive gaming hot seat.
We are.
We're moving past, the basic specs and really diving into the complex science required to get absolute, pixel-perfect, tournament-level precision with your mouse.
And this isn't just about buying expensive gear, it's about mastering input consistency.
Right.
That's right. I mean, if you're serious about competitive play, you know that the difference between an okay flick and a game-winning headshot comes down to tiny adjustments in milliseconds. So the sources we've pulled together, they're all optimization guides, professional settings manuals, and they're all focused on one thing: consistency.
Okay.
The goal here is making sure that every single millimeter your hand moves translates into the exact predictable amount of cursor travel on screen every single time.
And to make this really concrete, we're using one specific, incredibly advanced piece of kit as our case study today. The RG Harp Ace Mini, model 0716.
A beast of a mouse.
It really is. I mean, just to frame this for you, the Learner, it's engineered to be ultralight. We're talking only 49 grams. And it has the ROG Aimpoint Pro optical sensor. That sensor, on paper, can track up to 42,000 DPI.
42,000. It's a massive ceiling for sensitivity, but honestly, that number is incredibly misleading in a competitive context.
So our mission today is to unpack these sources and figure out how pros take a device like that, a high-fidelity device, and really tame it.
Exactly. Tame it, optimize it, not for raw speed, but for absolute reliability. And we have to start at the logical beginning, the metrics of aim consistency.
Okay, let's unpack the foundational math. eDPI, effective DPI. It's thrown around everywhere, but if you're new to this, it just sounds like jargon. What does it actually mean?
Right, so eDPI is the critical metric because it takes two separate variables, your hardware setting and your software setting, and it combines them into one functional number.
Simple as that.
It's simply your mouse DPI multiplied by your in-game sensitivity. So if you run 800 DPI on your mouse and your game sensitivity is at 1.0, your eDPI is 800.
That sounds perfectly straightforward. But I'm guessing there's a trap here, right?
A huge one.
If I set my eDPI to 800 in Counter-Strike 2, can I just copy that over to Valorant and expect the same physical movement?
Unfortunately, no. And this is probably the biggest stumbling block for anyone seeking consistency across different games.
Okay.
The sources all stress this. While eDPI standardizes your personal settings, the underlying sensitivity scale, it just differs drastically between game engines. So 800 eDPI in CS2 is a physically different turn rate than 800 eDPI in Valorant.
That really drives home why understanding your preferred physical movement is so much more important than just copying a number. And you can see this sensitivity difference reflected immediately in the pro player's preferences, right, across different genres.
Oh, absolutely. I mean, just look at tactical shooters like Valorant. They emphasize precise headshots, holding static angles.
Very small, controlled movements.
Exactly. Rapid micro adjustments in these short, intense bursts. So, what do the pros prioritize there?
Precision over speed.
Extreme precision over speed. The average pro eDPI in Valorant is incredibly low. We're talking 200 to 400. The median is somewhere around 250 to 280.
Can you give us an example?
Sure. A player like Tenzi, he runs 280 eDPI. He gets that by using 1600 DPI on his mouse times a 0.175 in-game sensitivity. The sources all agree anything over 500 eDPI for Valorant is considered really high because you just lose that fine control.
Okay, now let's compare that to Counter-Strike 2. The playstyle is different. You have more complex recoil patterns, maybe sharper angle sweeps.
Correct, and more reliance on big arm movements. CS2 pros, they generally run a slightly higher eDPI to handle those mechanics.
What's the average there?
It usually hovers between about 800 and 1200 eDPI, and you see a lot of variance even among the top players. Someone like Cesta Swampel runs a high sense at 1236 eDPI, but then you have Nico on the lower end at 560.
So there's still personal preference, but the whole range is shifted upwards from Valorant.
It is. The game just has different physical demands.
And here's where the numbers get truly shocking. If we look at tracking and high mobility games like Apex, the eDPI requirements just explode.
They absolutely do. In a game like Apex Legends, pros need to track fast-moving targets, often vertical targets, while doing these complex maneuvers themselves. That pushes the average eDPI way up to 1,000, maybe 1,600, or even higher. But the most extreme example is in games like Overwatch 2. For tracking and movement heroes, you can see eDPI averages soar to 4,800, 5,000, I mean even 7,000 plus.
Wow, I find that fascinating. The Valorant average is around 280, but an Overwatch player might need 7,000. What accounts for that? That massive 20x difference?
It's the classic difference between precision and agility. Valorant is all about stopping on a dime and making a single pixel-perfect shot.
And Overwatch.
Overwatch demands near constant 360-degree awareness. You have to be able to spin around instantly to track a tracer blinking behind you or a Pharah in the air. Your hand physically cannot move fast enough to do that if your sensitivity is too low.
Which brings us to the real superior standard. Since the eDPI numbers are basically useless for consistency between games, what's the universal measurement we should be tracking?
That is the cm360 standard. It just cuts through all the software nonsense. It's simply the physical distance, in centimeters, that your mouse has to travel on the mouse pad to make your character turn a full 360 degrees in the game.
And that's universal.
It's universal, it's reliable, and most importantly, it's trainable.
So if I find that, say, 30 centimeter 360 feels perfect for me in CS2, I can then just use a calculator to find the exact equivalent sensitivity in Apex or Valorant.
Exactly that. You're translating your muscle memory across different platforms. Pro FPS players almost always fall into this predictable, narrow band. They're aiming for a consistent 20 to 50 centimeter 3/60 no matter what title they're playing.
That's the core of it all.
It's the core of building consistent muscle memory.
It's amazing how much work goes into standardizing movement. All of that means nothing if the operating system is actively fighting against you.
Oh, this is a huge one.
Let's tackle the Windows interference. This is where it gets really interesting for you, the learner, because this impacts everybody, no matter what mouse you have.
This is a critical first step. Before you even touch the Heartbase Mini software, you have to ensure the OS is just sending raw sensor data to the game. Competitive aiming demands what we call pixel-perfect 1.1 tracking.
Meaning the PC can't mess with the signal.
It can't interpret it. It can't change it. The input has to be raw. Think of it like this. Raw input is like speaking directly to the sensor. Windows mouse acceleration is like having this overzealous interpreter who changes your sentence based on how fast you talk.
That's a great analogy. The meaning gets lost.
The input is no longer raw.
And the single biggest culprit for that inconsistency, Windows 11 mouse acceleration. It's still on by default a lot of the time. And Windows gives it this really benign sounding name, enhanced pointer precision.
It must be disabled. I think everyone listening has had that moment where you panic flick really fast and suddenly you're staring with the ceiling.
Oh yeah.
That's Windows deciding to boost your speed. Acceleration takes your physical movement and it scales it depending on how fast you move the mouse. A slow 5 centimeter swipe might move the cursor 200 pixels, but a fast 5 centimeter swipe might move it 400.
Which just kills any hope of reproducibility.
It destroys muscle memory, so the instruction is simple. Go to the Pointer Options tab in your mouse settings, and you in and check that Enhanced Pointer Precision box.
Absolutely essential. But that's only half the battle, right? There's a second, equally crucial Windows setting.
Yes, the pointer speed slider. For a true 1.0.1 input ratio, that slider has to be set to the exact middle. That's level 6 out of 11.
Why that specific number? What happens if I move it one notch lower, 2.5?
It introduces OS scaling, which is exactly what we're trying to eliminate. At the 6.11 setting, Windows is processing the input at a 1.1 ratio. It's neutral.
Right.
If you move it to 7.11, every pixel input is scaled up by 1.5. If you move it down to 5.11, your cursor movement is cut in half. You just want Windows to be a straight pipe for data, not a processing unit.
I remember before I knew about the 6.11 rule, my cursor always felt just a little bit unreliable. It felt like dragging through mud on 5.11 or kind of floaty on 7.11.
That subtle scaling is enough to throw off your precise movements. It's the difference between a direct connection and an unnecessary software layer getting in the way.
And there's one last, often overlooked Windows tweak that can ruin stability.
Especially with wireless devices like the Heartbase Mini, it's power management.
Windows trying to save a few cents on the power bill at the cost of our KD ratio.
Precisely. You need to go into Device Manager and disable power management for the specific USB hubs that your mouse or wireless dongle are plugged into. If you don't, Windows might decide to throttle or power cycle the device mid-game to save electricity.
Which would look like, what? Stuttering. Input lag.
Stuttering, input loss, massive latency spikes. You need an uninterrupted flow of power.
So, with the Windows interference gone, we have a raw, consistent pipe for our input data. Now we can finally dive into the hardware itself, the ROG Heartbase Mini, and how to optimize its features in Armory Crate.
Right. And we start with a DPI strategy. The Heartbase sensor goes all the way up to 42,000 DPI. But why do the sources all say that pros limit themselves to just 800 or 1600?
That's a great question. Isn't higher DPI supposed to be better? More data points?
It does offer more data points, yes, but often at the cost of stability and fidelity. Most high-end sensors achieve their maximum fidelity, their most raw, unfiltered precision in that 400 to 1600 DPI range.
And above that.
Once you go higher, especially into the tens of thousands, the sensor often has to rely on digital signal processing or interpolation to hit those numbers. That can introduce noise, jitter, inconsistency. We want stable, controllable input.
So the recommendation is basically to tame the beast.
Exactly. Suggested DPI for FPS pros is 800 to 1600. And the key recommendation is to configure only 2 to 4 stages, say 400, 800, 1600, 3200, and then disable all the other default stages in the software.
Why disable?
To prevent accidentally hitting the DPI switch button during intense play. That is catastrophic.
Let's move to the headline feature of these modern mice.
Yeah.
Polling rate. Define that for us, and then let's get to the 8,000 hertz reality check.
Sure. The polling rate is the report frequency, how often the mouse tells the PC where it is. 1,000 hertz means 1,000 reports per second, which is a 1 millisecond. The Harper's Ass Mini does support a staggering 8,000 hertz wireless polling rate. That's a report every 0.125 milliseconds.
But here's the catch, the source's highlight. That 8,000 hertz feature isn't just plug and play for maximum performance, is it?
No, it is not.
It sounds like we're talking about buying an accessory and maybe even upgrading our entire PC just to run a setting that a lot of pros might turn off anyway.
That's the reality check. The sources are clear. To reach 8,000 hertz wirelessly, you need the separate ROG polling rate booster accessory to maintain that signal integrity, and you need a truly high-end system to process that much data without micro-stuttering.
What kind of system are we talking about?
Intel i7 9th Gen or newer, and a monitor that's running at 240 hertz or higher. If your CPU or your monitor's refresh rate can't keep up, that high polling rate actually introduces latency. It doesn't eliminate it.
So while the tech is incredible, what are most elite players actually running for consistency in a high-stakes match?
The competitive sweet spot, it really remains 1,000 to 2,000 hertz. That range is stable, it's universally supported by game engines, and it's minimally taxing on your system.
What if you do have a high-end setup?
For those with, say, a 360 hertz monitor and a top-tier CPU who want that slight edge, 4,000 hertz is considered a pretty optimal balance. But you have to test it for stability in your specific game. Older engines can really struggle with anything above 2,000 hertz.
Okay, let's talk about lift-off distance, or LOD. This seems crucial for players who use those big arm sweeps and need to lift and reposition their mouse.
LOD is exactly what it sounds like. It's the height at which the sensor stops tracking when you lift the mouse off the pad. For maximum precision, you have to set the LOD to low. We're talking around 0.76 millimeters to maybe 1 millimeter.
Just to put that in perspective, that's thinner than a credit card.
It's a microscopic measurement. And that low setting is vital because it stops the cursor from jittering or moving unintentionally when you lift and reset the mouse, which is a core part of aiming for low sensitivity players.
Next up, angle snapping. What is it and should we use it? It sounds like it would help you snap to a straight line.
Which it does, and which is why in a competitive context it must be disabled. It artificially straightens lines of movement. If you try to draw a perfectly horizontal line with your hand, you'll naturally have tiny vertical wobbles. Angle snapping tries to correct those into a perfectly straight line, which interferes with raw input and ruins your ability to make micro corrections and diagonal shots.
And finally, a quick note on surface calibration.
Yes, the Aimpoint Pro sensor is advanced, but you should still run the surface calibration tool in Armory Crate. It customizes the tracking profile specifically for the texture and material of your mouse pad. It just improves tracking consistency.
So we've set the hardware, we've cleaned up Windows, we've maximized the raw data pipeline. The last hurdle is personalizing your sensitivity, finding that perfect cm360 for you. The sources really emphasize something called the PSA method.
The PSA method, or perfect sensitivity approximation, it's an iterative process. It's based on mechanics and feel, not on just copying a pro's settings. You start with a functional baseline cm360, and then you begin testing.
How does that testing work? What are we looking for?
The core of the method is strafing in-game while trying to keep your crosshairs locked onto a static target, like a pole or a doorway. The first test finds your broad range. You test 2 wide intervals, half your current sensitivity, and 1.5 times your sensitivity.
Okay, so that quickly tells you if you're way too fast or way too slow.
Exactly. If your crosshair keeps falling behind the target as you strafe, your sensitivity is too low. You need to test a faster setting.
And once you've found that general range,
Then you start the micro tests. Mirror the range, say testing 0.8 times and 1.2 times your sense, and you just repeat the strafing test over and over. You're looking for that sweet spot where keeping the crosshairs on target feels smooth, almost effortless.
That sounds like a long process, but a rewarding one. What if the learner wants a more data-driven shortcut?
Well, AimLab offers a fantastic solution for that. It has a settings optimizer tool that runs you through specialized tasks to analyze your performance. It then automatically suggests an optimal sensitivity based on that data, which gives you a great starting point for the PSA method.
And if you want to check what the world's best are doing or translate your hard-won cm360 to a new game, what are the go-to resources?
There are two absolutely indispensable resources here. First is ProSettings.net. It's the industry standard database that lists the exact DPI, sensitivity, and gear for thousands of pros.
And second?
The second, and maybe more important for consistency, is mousesensitivity.com. That is the specialized calculator you need to convert your perfect cm360 from one game engine into its equivalent sensitivity number in a totally different game.
And a final stability recommendation, especially for a high-performance wireless mouse in a terminal setting. Connection stability is paramount.
It is. For absolute stability, wired mode is king. But if you have to be wireless, always use the 2.4 gigahertz RF connection. And crucially, position the receiver within 30 centimeters of the mouse and keep it away from USB 3.0 hubs because those can cause interference.
And Bluetooth.
Bluetooth is a definite no-go. The latency is just inherently higher and less stable.
We have covered a massive amount of ground here. We've gone from the theory of eDPI all the way through Windows optimization and to a deep dive on hardware settings for the Heart-based Mini.
Yeah, the ultimate checklist for you, the learner, it really boils down to 4 key steps. First, fix your mouse DPI in that reliable 800 to 1600 range. Second, set your Windows pointer speed to 611 with enhanced pointer precision turned up F. Third, use a stable polling rate, 1000 to 2000 Hertz is the safe minimum. And finally, find your personal cm360 through rigorous testing. That combination gives you the pixel-perfect 1.1 tracking you need to build muscle memory.
So we've spent a lot of time on optimizing the Heart-based Mini to use its incredible 8,000 Hertz potential. 8-fold increase in report speed over the 1,000 Hertz standard. Yet, our sources consistently show that the vast majority of elite players still rely on the established lower 1,000 to 2,000 Hertz range for consistency, even when they have that 8,000 Hertz capability.
They do.
And this raises a really important question for you, the learner, as you start this journey. If the technology offers 8 times faster reporting, but competitive consistency still favors the slower, older standard, are we spending more time and resources optimizing our hardware than we spend optimizing the most crucial variable in competitive gaming, the human sitting in the chair?